Okay, so today we will see some examples on how to solve systems of linear equations using elimination. But by elimination, in this case, I only mean addition and subtraction of equations. So let's look at our first example. We have 4x plus y equals to 3 and negative 4x plus 3y equals to 17. So what we do here, first we look at our coefficients for the variables, and we see that there is no way on canceling out the y without modifying the coefficient of the y, but we see that the x's have 4 as their coefficients, and so that's very useful. But now we see that one of them is negative and the other one is positive. This means that we want to add in order to cancel out the x's. So we add both equations. When you add them, you know that these two will cancel out the x's, but then if we add y plus 3y equals to 4y, and then 3 plus 17 equals to 20. So now we solve for y, we divide both sides by 4, we get y is equal to 5. Now we just plug into either one of the equations to find x, so let's plug it into the top equation. So 4x plus 5 equals to 3. 4x equals to negative 2. So x is equal to negative 0.5, negative a half. So this is our unique solution. There is only one solution in this case. Let's look at another example. Right here, we see that the coefficients for the x's are the same and the coefficients for the y's are the same. But one of them will cancel them out, subtracting, and the other one adding. So we know that these two would cancel out if we were to subtract, since the sign of the coefficients is the same. Or on the left side, on the x, we can add them and that would cancel them out since their signs are opposite. Just for fun, let's subtract them since we already did addition before. So if we were to subtract, like I said before, you could think of it as just multiplying the bottom equation by negative 1. So it's actually adding. We multiply the bottom equation by negative 1, 2x minus 7y equals to 5. So we can add them. Another way of doing it is just thinking of it like a simple subtraction. So 2 minus negative 2 is 4x. But you can see that here we get the same thing, 4x. So you can do it either way, whatever is easiest. But let's do it in both sides right now. So 7 minus 7 equals to 0, or 7 plus negative 7 equals to 0. And then 5 minus negative 5 equals to 10. And 5 plus 5 equals to 10, of course. Now we solve for x. We know that we have to divide both sides by 4. So we get that x is equal to 2.5. Now we just plug in to find y. So in either equation, as I told you before, so 2 times 2.5 plus 7y equals to 5. We know that this is equal to 5 right here. So we can cancel these two out, so 7y is equal to 0, y is equal to 0 then. So this is our unique solution. We have only one solution to these systems of linear equations. Now, our next example, we have negative x plus 2y equals to 6 and x minus 2y equals to negative 6. In this case, you can cancel out the x's by adding them. And you can cancel out the y's by adding them. So I guess there's no other way. Let's add both equations. So negative x plus x is equal to 0. 2y minus 2y is equal to 0. And 6 minus 6 is equal to 0. So we get 0 is equal to 0. As I told you before, when the variables cancel out, it's a giveaway that there will be either no solution or infinite many solutions. In this case, since this is a true statement, 0 is equal to 0, then we know that we have infinite many solutions. Very well. Let's look at another example. Here we find that 3x minus 4y is equal to 8, and negative 3x plus 4y is equal to 7. We see that to cancel out the x's, we can add them. But to cancel out the y's, we can add them as well. So we encounter kind of the same thing that we encountered before. We just want to add both equations. 3x minus 3x is equal to 0. Negative 4y plus 4y is equal to 0. And 8 plus 7 is equal to 15. In this case, 0 does not equal 15. This is a false statement, so there is no solution. That's it. Thank you.